Welcome to qnawire.
So in this problem, we're going to be solving for an angle theta at which a ball is released after being whirled around in a circle. And that ball is labeled with this little black dot here, just for reference. And the other piece of information that we're given, apart from our angle phi, which is labeled as 35 degrees, and is the relationship between our distance d and our distance r, which is d equals 10r. And so there's an unlabeled angle between phi and theta, which we've labeled alpha in this problem. And solving for alpha is actually going to be the key to getting our answer. So what we need to realize is that we can actually connect the endpoints of R and D with another line, and then we get a right triangle. And using this, we can then use the properties of trigonometry to solve for our answer. So when we look at our angle alpha, we can say that the cosine of alpha is equal to r over d, or the adjacent side over the hypotenuse. And now we can rewrite alpha in terms of the angles that we do know. The important thing to realize here is that the total semicircle here must have a total angle measure of 180 degrees because we know that a full circle has an angle measure of 360 degrees. So we can rewrite this as the cosine of 180 minus phi, which is 35 degrees, minus theta is equal to r over d. And now we can solve for theta. So we can now say, rearranging a little bit, that theta is equal to 180 minus 35 minus the inverse cosine of r over d. But since we know that d is equal to 10r, this is actually just the inverse cosine of 1 over 10, which we can plug into our calculator, and then we get 84.26. Now, all that's left to do is plug in 180 minus 35 minus 84.26, and that is equal to 60.74, which we can then round to 61 degrees. And that is our